In this video, we'll be looking at composite functions, both in creating and decomposing them. The first example we have is a very basic example, and we are to find two numeric values by composing two functions, one with the outer function being f, the other with the outer function being g. So we'll start with f of g of 3. Well, the first thing, when you think PEMDAS, is start on the inside. So let's step over here to the side and figure out what g of 3 is. So g of 3 is equal to 2 times 3 minus 3. Well, that would just be 6 minus 3, which is obviously 3. So this is equal to, having done that work on the side, f of 3, which is equal to 3 plugged into f of x, which is 3 squared minus 1, which is 9 minus 1, sorry about that, which is 8. So your answer would be f of g of 3 equals 8. And that was supposed to be an 8, and I don't know what happened. There you go. Now, on to the next one. So we have, for this one, we are to find g of f of negative 2. So again, we can step over to the side and figure out that f of negative 2 is negative 2 squared minus 1, which would be 4 minus 1, which would be 3. So this is actually g of 3, which we just found at the beginning of the problem, and g of 3 was also 3. So that's our answer, and we're done with number 12. So the key to those is find what's inside and substitute that into your outer function and get your final answer. Number 16. Now this is a bit more work, and how much work it is really depends on the functions involved, because we'll have a good bit more scratch work here on number 16 than we will our next example, number 20. So this one tells us to find f of g of x and g of f of x, which means we're not plugging numbers in. We're going to plug a function into a function, and then we are to state the domains of each of these two composites. So we'll start with f of g of x, just because that's what they ask us to find first. No particular significance to the order here. But this is the way I recommend you do this. You're going to copy the outer function, and in this case that's f, and when you do, you're going to make parentheses where you see x, but you want to make sure you make them big enough to plug g inside it. And g is a rational function, so we're going to make this kind of big. So x squared, or whatever we're going to square, minus 1. That's what the f function does with whatever we give it. Well, now we're going to plug into that what g of x is, which is 1 over x minus 1. And the only thing we can do to simplify this down to a cleaned up answer, a simplified answer, is to square the 1 on top and get rid of the parentheses, and then rewrite the bottom as x minus 1 squared, and then leave the minus 1 on the outside. So that's our f of g of x. Now we have to talk about the domain. Let me fix that so that I'm not running over that 1. So this is my answer for that one. Alright, but I need the domain for this one. So when you're looking at the domain of a composite function, where in our quotient it started with the most restrictive, or if you add, subtract, multiply, or divide, it starts with the intersection. In composites, it's going to start with the inside functions domain. So let's go back, and I should have done that to start with and didn't, so we'll make up for it by doing it now. Alright, so we're going to find the domain of each of these functions, and for f of x, and we'll do that over here in this little spot, would be all real numbers because f of x is a polynomial. And g of x being a rational function, has one restriction, and that is where the denominator equals 0. We know that x is not allowed to be 1 because that would make the denominator 0. So we include negative infinity to 1 union 1 to infinity. So those are our domains we are referring back to. Well, on f of g of x, the first one we just did, our inside function was 1 minus x over 1. So that's the domain we're going to start with. And the only way we change it is if there's a new restriction by combining them in the composite of plugging one inside the other. And in this particular case, there is no new restriction because the x minus 1 is still in the denominator, so the domain of this one, this f of g of x, is, and you can actually, let me show you this too. I've debated about including this, but just for those of you that are trying to step up your game, you can do a subscript on your d, especially in a problem like this where you're doing two different problems, and you could do f of g of x as your subscript to show that this is the domain for this one, and it would be negative infinity to 1 union 1 to infinity. And then we go find g of f of x. Need one more parenthesis there. Alright, so now I'm going to copy g, which is 1 over x minus 1, and leave room to put x squared minus 1 in x's place. So I put 1 over, and then I'm going to put a wide set of parentheses so I can get that binomial in there, minus 1. Now I'm going to go back and substitute f of x in. So I'm going to put x squared minus 1 on the inside. So the starting domain of this one, remember, will come from the f function, which I just wrote in orange. But we're going to go ahead and simplify this down to 1 over x squared minus 2. So that is my newly simplified g of f of x. And the domain of this function started with all real numbers because the inside function is x squared minus 1. But we clearly have a new restriction because now we have x squared minus 2 in the denominator, which was not there in either of the original functions. So we know we've got a restriction to handle here. So we know that x squared minus 2 is not allowed to be 0. So we set x squared not equal to 2 when we add 2 to both sides, and then that means that x cannot be plus or minus 2. So we have two restrictions because of this new denominator that resulted. So again, starting with all real numbers, the first restriction we would run into, and I will again show you that more sophisticated way of showing your domain. So subscript g of f of x this time is negative infinity to, the first restriction we would run into is negative 2 union negative 2 to 2 union 2 to infinity. And it's a really good habit to get into to graph these functions just to verify the domains, especially since this is a new kind of upper level way of thinking about your domains. So let's look at the domain of the first graph. And now when you graph these in your calculator to check them, you need to graph them exactly like you see them. So we're going to graph first f of g of x, and let me see if I can copy this one little thing here. I don't think it's going to let me. It won't let me. It's not going to let me do it. Alright, so I'll just write it the way it's. In fact, no, I'll tell you what, I'm going to just bring in the picture that I took of the graph of the first one. Make sure, I think this is it. Yes, and you can see that I typed it in my calculator exactly like we wrote it before we simplified it, because that's how you need to graph them to check them. And here's the picture, and we can see by this picture that we have a problem at 1. And if you look back at what we did for our domain, what did we say? We said our domain was from negative 1 I'm sorry, negative infinity to 1, and then from 1 to infinity. So let's match that up with our picture. So here's our negative infinity to 1 piece, union to the other side, 1 to infinity. Right, now let's look at the one for g of f of x, and here it is. And again, we have a three-piece graph with our three-piece domain that we found. So again, let's refresh our memory on that domain. That was, let's see if I can get a new color to circle it and highlight it here. This was our domain for the second one. So it went from negative infinity to negative 2. And again, we will add that to our picture. So negative infinity, oh, that light green doesn't show up on the white. I think I learned that. So negative infinity to negative 2. And then this piece down here in the middle is our negative 2 to 2, but not including our negative 2 and 2. And then this third piece over here is our 2 to infinity part of the graph that goes with our domain. So these graphs are good for confirmation purposes, just to help you see that the process of using the inside domain and then restricting it based on what shows up in the function that wasn't there to start with does in fact give you the right domain. Alright, let's look at number 20. This is the exact same set of directions, but this one turns out to be a much simpler problem just because of the nature of the functions involved. We should start by looking at the domains of the two original functions. I won't forget that this time. And the domain of x cubed is all real numbers because it is a polynomial. And then we can look over here at this, and there's a part of your brain that sees this root symbol, but you're completely okay in this one because that's actually a 3, and any odd root allows all numbers, because if you take the square root of negative 8 you get negative 2. It's legal, it works, as we said in the other video. So any odd root is also going to be all real numbers. So in this one we already know that both of them are going to start out with all real numbers. And we are finding first f of g of x. So again, we copy f with room to put g of x inside it, and f of x is just x cubed. So now let's switch colors to put g of x inside it. So that's a cube root of 1 minus x cubed, and then in this instance the cube root and the cube cancel and leave us with 1 minus x cubed as our function. And since there's no new restriction that would prevent us from using it, the all real numbers is the same. And then when we do g of f of x, we're going to write g first, which is the cube root of 1 minus whatever goes in it cubed, and in this case what's going to go inside it is x cubed, and so the only thing you can do to clean that up is the cube root of 1 minus x to the 9th. And again, because it's a cube root, there's no new restrictions. The domain of this one is all real numbers as well. And on 24 and 25, these are super simple and students find them very confusing. You're to find f of x and g of x so that we can see this function as f of g of x. So in other words, g of x is our inside function and f is our outer function. Well, the easy thing to see here is that what's inside is x cubed plus 1, or at least that's easy to me. So you're looking for what's inside something, and parentheses will sometimes be there but not always. So our g of x is x cubed plus 1, and our f of x is the outside function, the squaring function, so that's just x squared, and that's all you have to do for these. 26, same thing. We're trying to see this as f of g of x. This one's less obvious, but I wanted to show you this one just to let you know that anytime you see a rational function, try to make the bottom your inside function, and that works here. So in f of g of x form, our g of x would be the denominator, which is x cubed minus 5x plus 3, and our f of x would be 1 over x. Now, if you wanted to check your answer to these, all you'd have to do is actually use your answer like it was a question and recompose them to make your composite to make sure it works. And it should. And that's the end of this video. One more to go.